Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi, and welcome to this edition of the GOTO Book Club. My name is Kief Morris. I'm a distinguished engineer at Thoughtworks and the author of the book, Infrastructure as Code. But today we're going to talk about, with the author of the book, Fundamentals of DevOps and Software Delivery, Yevgeniy Brikman. Yevgeniy, I've kind of been aware of you and followed you for years, and we've corresponded on various things. So would you mind just kind of sharing with people, about your journey and who you are?
Sure. Thank you for having me. Great to chat today. I actually started my career in software as an app developer, front ends, back ends, Java, Scala, Python, Ruby, etc. But the way I ended up writing a book on DevOps and in this whole DevOps side of the world is every time I would go to build an app, I'd have it running on my computer. I'd be really excited. And then I'd want to expose it to the rest of the world. And that process was a little less exciting and was actually really, really painful. Like I just always found it very, very painful to get something out into the world in a way that was secure, scalable, highly available. And then the real turning point in my career was I was working at LinkedIn. This is around 2011. And again, working on some back-end stuff, infrastructure stuff, web frameworks. And from the outside, LinkedIn was doing great. The company had just had its IPO. Revenue was growing like 100% year over year. The website had something like 100 million members. 2 new members were joining every second. So like things looked amazing. Yeah. On the inside, we could not deploy. At the time, we tried to do deployments roughly once every 2 weeks, the sort of like deployment train model. And it was a very painful manual process. And we had one deployment where we tried to roll things out, and it broke a bunch of stuff. So then we put together some fixes and rolled those out, which of course broke more stuff. So we put more fixes together and rolled out, and we kind of repeated it. It went on for 2 days, maybe even more, with people like awake the whole time, and we just could not stabilize it and had to roll everything back. So here's a company that's in theory worth something like $10 billion, and we cannot update our own product. We just cannot roll out changes. And what that led to was something called project inversion. And what we did is we actually froze all product and all feature development for months. The whole company completely froze everything. And it was an all hands on deck exercise to fix how we did software delivery. And I do mean all hands on deck. So the ops team was involved, all the back end, front end devs. So I got pulled in, all the product managers, all the designers, everybody was just working on infrastructure, software delivery, et cetera. And I guess what we ended up doing today, we'd probably call that like a DevOps transformation, something like that. I don't think we really were using those terms at the time, but we put in place like CI/CD and trunk-based development and automated deployments and feature toggles and a whole bunch of other things that, at least for me, were fairly new. And
continuous delivery, isn't it? Like as a overarching thing, really.
Yeah, exactly. And the result was we could deploy now hundreds of times per day with far fewer issues. So it was a very good result, but the process to get there was really, really painful. So that really kicked me over to this kind of DevOps side of the world. And a little while after leaving LinkedIn, I started a company called Gruntwork, where we focus on that. We're trying to kind of give companies that sort of experience out of the box. And then I ended up writing some books in the DevOps world as well. I wrote Terraform Up and Running, and most recently, Fundamentals of DevOps and Software Delivery. So in some weird way, I now, like my whole career is focused on stuff that I found really, really painful. But I guess where there's pain, there's opportunity. And just, it's one of those things where it's time to start a company where you see something, you're like, there just has to be a better way to do it. Like this can't be the way it is, right?
Yeah. I mean, that kind of in your background, that combination of being like a book author and so on, and also, a company founder, And it's really interesting because it kind of strikes me as like there are two different manifestations of like there's got to be a better way, right? One is to like write a book and tell people here's how to do it, and then one is to help provide the tools that people can actually use to do it.
Exactly.
Yeah. So with this book, Fundamentals of DevOps and Software Delivery. So in terms of DevOps, like as a term, this is one of these things that sometimes, I don't know, controversial, like people have different definitions, and people say DevOps isn't a technology thing, it's a culture and so on. And your book strikes me as, it's a very pragmatic take on DevOps. So like when most people who are like, in the field, working in a company, facing those kind of problems you described at LinkedIn, like when they talk about DevOps, this is kind of like what they mean. So I'm curious in your take of like the definition of DevOps and how you feel this book fits within all that.
Yeah, I've actually been really frustrated with the discussion around DevOps because a lot of the books I see, a lot of the talks, they spend way more time telling you what DevOps is not rather than telling you what it is. No, it's not that. It's not a job title. It's not a team. It's not a this. It's not a that. You're like, I mean, I agree, but like we still should give people a little more of like, what is it?
Yeah.
And I've seen kind of these half definitions and things like that. For me, and with this book, I'm trying not to get bogged down in that debate so much. For me, what matters is this. When most people are talking about DevOps, what they're looking for is typically, how do I do software delivery efficiently, right? They're working at a company where every time they go to deploy, like my experience at LinkedIn, it's this manual, broken process. Nobody gets to sleep. Everything breaks. Things take forever. And they want to know how to do it better. Like that's what most people care about, getting the software out in front of their users in a way that's reliable, that's secure, that's efficient. And so that is the focus of the book. And that's really almost the way I define DevOps here, is it's a methodology for doing software delivery efficiently. So yeah, that's what the book focuses on, is really these nitty gritty details. These are the techniques, the technologies that so far we have figured out as an industry to get your software in front of your users effectively and securely and repeatably.
Yeah, that's cool. A lot of the conversation these days is like using the phrase, platform engineering and that kind of thing. And you also get like IDPs, which I've seen defined as internal developer portal or internal developer platform. And it strikes me there's a lot of stuff in this bucket of, okay, I've got my application and then there's everything underneath it that I need to deliver it, to run it, and so on, and manage it. And different terms that seem to be talking about, it's that classic thing of the elephant, different people, the blind philosophers or whatever it is, touching different parts of the elephant and saying, oh, it's a snake, it's it's a this, it's a that. So how do you kind of frame, I guess, the different aspects of what is really quite a lot of stuff that sits underneath the application and could be termed platform or infrastructure or whatnot?
There's a lot of stuff there. If we're going to keep, I guess, our chat from being, 15 hours long, I guess there's a few things we can look at. I'll focus on this. In a lot of people's minds, you kind of have a bit of a spectrum, right? You kind of have the stuff to manage your infrastructure over here. And then over here, you kind of have the stuff to manage your apps. So by infrastructure, I mean, servers, load balancers, networking. And then by apps, I mean, it's like your Java, Python, Ruby, whatever app that is maybe a web service or something like that.
Yep.
And the question is, how do you manage these things? How do you do it in a way, again, that's effective, that's secure, repeatable, reliable? I think one thing we've learned as an industry is not to do it by hand. So what we call click ops, where you just click around and deploy everything manually. That works fine at a very, very small scale. You're doing a side project. You're doing something for fun. Great. Click ops is terrific for that. But once you're like at the scale of a company, there's lots of employees, multiple environments, things of that sort, that falls apart really quickly. And so the industry has been through a whole bunch of ways of how do we automate these things? How do we do this essentially through code or through UIs or through this kind of tool and that? And I think where most things have landed is kind of in two rough buckets. One hand, you have these infrastructure as code tools, which your book talks about quite a bit. And those tend to be, as the name implies, for managing the infrastructure, for your servers, your load balancers, your networks. And they work great for these things that change relatively infrequently, on the order of days, right? You're not like redeploying your entire networking configuration every single day in most cases. And then on the app side of the house, you have a bunch of requirements that change much more frequently, right? You have things like, well, how do I auto scale my app if traffic suddenly spikes? How do I do auto healing if, a server crashes? How do I recover automatically? How do I load balance? How do I allow services to communicate with each other? How do I schedule them? So place them more efficiently across the servers that I have. So these things change on a matter of seconds. Mm-hmm. And so there's tools that tend to focus on that space, which the terminology that I use is application orchestration tools. So that's kind of the realm of Kubernetes. That's the realm of things like Lambda and auto-scaling groups or auto-scaling sets, or depends what you're deploying into.
Yeah.
And so there's a bunch of tools for managing, but generally what most folks do is they will manage their infrastructure with the infrastructure as code tools. So you might use Terraform or you might use Pulumi or something like that. And then you'll manage your apps with the orchestration tools like Kubernetes, which of course leaves a bit of an open question, which is, well, how do you configure what you actually put into Kubernetes? And I think I've seen a bit of a split as well. Some teams use infrastructure as code tools to configure the apps that go into Kubernetes.
Right.
So you might use Terraform or Pulumi or OpenTofu to basically say, here's a service and a deployment and whatever pods I need in Kubernetes. And that has some nice advantages in the sense that if you're using that same tool to manage your infrastructure and your apps, you kind of have one tool set to manage all the things. There's also a subset of teams that tend to gravitate towards tools that are custom built for managing the applications. So in the Kubernetes world, you might use Helm, for example, is a very common tool. In the serverless world, there's Serverless Framework and SAM. And those tools usually have something specifically built for apps. So for example, if you're trying to use Terraform to manage your Lambda functions and API gateway, it works, but it tends to be verbose and you don't really have a way to test locally. So if you use Serverless Framework or SAM, well, you have a way to run it locally, and they tend to give you a slightly more concise way of defining all the routes and configurations and things like that. Mm-hmm. So that's what I see. The one thing I'll add, and kind of the detail that I skipped, is there's a bit of a layer in between those two as well, which is CI/CD. Basically, how do you build your app? How do you test it? How do you package it, etc.? So there's some degree of connective tissue, usually something like a CI/CD server, maybe GitHub Actions, maybe Jenkins, depending on what company you're at. Or again, there's application-specific ones like Flux and Argo for the Kubernetes world. Yeah. And so I guess if you put it all together, where I've seen most companies go, and there's obviously a million variations in here, but the most common approach is you have the ops team using an infrastructure as code tool to set up the basic infrastructure. So they use, let's say, Terraform to lay down the network, spin up some databases, and set up the orchestration tool. So maybe they spin up a Kubernetes cluster. And then the dev team is using some set of tools to say what apps to put into that orchestration tool, like into Kubernetes. So again, that's maybe a Helm chart, or maybe that's Terraform. And they have a CI/CD, maybe a template for GitHub Actions or something like that, which is then how they're able to update that app once it's in the cluster. And so if you kind of squint at it, what you realize is the tool for the orchestration, so that's Helm or Terraform or whatever it is, and your CI/CD stuff, that is your API. That is the API between dev side of the world and ops. That's kind of the API between the app side of the house and the infrastructure side of the house. Yeah. And the teams that do that really efficiently, they really focus on what that API is. What should that be experienced? So you mentioned, internal developer platforms, things like that. That layer is what a lot of those things are targeting, is how do I get that app into a developer's hands, sometimes through self-service, that's efficient and manageable and standardized and so on.
Yeah. Yeah, like I said, that's a lot of stuff.
There's a lot of moving parts. Yeah, that's the short summary.
Yeah, I like what you're saying around that kind of, you think about laying the layer of infrastructure and potentially using infrastructure as code tools for that, and then laying the applications on top of that, like deploying those and configuring and integrating and where those boundaries are, and the fact that they are different, right, depending on the tools that you use. one of the interesting categories is there's a lot of, especially in the Kubernetes world, there's tools that are trying to put the infrastructure stuff within that, or they do put the infrastructure configuration kind of closer to the application. So I'm thinking of things like Crossplane, which like builds on, I think it's the ACK library for AWS. And it's basically being able to kind of put controllers so that within your application deployment, you kind of specify, and here's the infrastructure that my application needs. So I'm curious if you have kind of much of a, what do you think of that kind of stuff? What have you seen?
Yeah, Crossplane is really the only player I've seen in that specific space. True. And it's definitely an interesting concept. So for those folks that haven't used it, they're almost flipping the model on its head. So I was talking about how a lot of teams use infrastructure as code tools to deploy the infrastructure and sometimes to deploy the apps as well. Right. Crossplane says, no. We're going to use the tools that we use to deploy apps to also deploy our infrastructure. So you can, for example, put together YAML that looks a lot like what you would use to deploy an app into Kubernetes. But when you run kube control apply on that YAML, it actually spins up infrastructure. So it spins up servers or databases or networking or whatever else you need. The advantage of that, the claim, I think, is, well, we're using, we have so much YAML already for our Kubernetes stuff. Why not do everything with YAML, right? That's kind of the argument. It's a consistent thing. And it's not unreasonable. And I've seen a bunch of teams try it. My own experience, which is, a limited slice of the companies out there, is not a ton of success with that approach. It sounds like a good idea, but there's all sorts of growing pains. There's issues with it being kind of like a weird leaky abstraction. There's a bit of a chicken and egg. It's like you have to spin up infrastructure, a Kubernetes cluster, so that you can use it to then spin up the rest of your infrastructure. So there's a little bit of, what's that term? There's like an impedance mismatch. I don't know if you are, if you've seen that with like ORM tools and databases where it's like, they can work really well for simple cases, but when things get messy, it's like, okay, now I want more control over what's happening. And so I haven't seen a ton of success with it, but it is yet another approach that's out there of the many, many flavors that are out there.
As with you, I haven't seen necessarily a lot of really successful implementations using that. I guess just what I find interesting is because I think that impedance mismatch is there, right? It's like as you use I think it's a great analogy with the object relational mapping things with databases and object-oriented code. Like you have object orientation, structure, and then you're trying to map that onto a relational database, and they're different things. And so how do you do that? And so with infrastructure and applications, I think that's a thing. And I think, you see pain points either way, like whichever way you go, as you say, infrastructure people deploying the applications, well, that creates issues. I guess I like the idea of trying to rethink those boundaries of, so my application needs certain types of infrastructure, and maybe I should have that kind of defined closer there. Maybe not down to the detail of here's the details of how to configure my database cluster, for instance, but just the fact that here's what I need from my database. And then, so I think, and this is kind of me going off of but I feel like there's room to kind of experiment here and move beyond that. I think those things where you're building it into as we're talking about with the Crossplane or whatnot, one of the kind of things that I've seen and I've heard from people using it is more around the fact that it uses the reconciliation loop. And so you're basically you push code to say, here's what my infrastructure should be. And then you kind of wait and see what happens. And it might work, it might not, it might fail, it might retry a zillion times, and you kind of don't know what's going on. And so I know that makes a lot of people uncomfortable too.
Yeah, the reconciliation loop though, it's like a double-edged sword, right?
Yeah, exactly.
On the plus side, it ensures, in theory, that your infrastructure is exactly what you specified you wanted it to be. And so in theory, if somebody comes in and changes it by hand, the reconciliation loop should be like, hey, wait a minute, these two no longer match up. Let me fix it again.
Yeah.
And in the app world, that's great. That's how you do, for example, auto healing, like I mentioned, right? You said, I want 3 copies of this thing, and then the server died or somebody took it down, and now you only have 2 copies. Then the reconciliation loop spots that and spins up the 3rd copy. So great, we're up again. In the infrastructure world, that can be a good idea, but as a lot of folks find out, infrastructure is different than apps. So, for example, if you said, I don't want there to be a database, and then somebody created a database, and your reconciliation loop's like, well, better go delete that database.
Yeah.
Like, that's not necessarily a good thing, right? So you have to be a little more careful. And you run into that a lot. This is what I mean by impedance mismatch, right? In the app world, we're used to, for example, deploying things by doing a zero downtime rollout, and maybe you do a blue-green deployment. You don't have that in infrastructure, right? Like, you have a database or you don't have a database. The network is configured or it's not. And so those differences are important. And if you lose them, you do potentially have a bit of a foot gun situation there where you can really hurt yourself pretty quickly.
Yeah. I think the one thing I always advise with these kind of technology, with anything anyways, but like with this stuff in particular, is it's observability, right? And the monitoring. Like, you really need to know, like, if something is going to be, even for automatic healing, the self-healing stuff, it's like you kind of need to know what's going on, because things can get stuck in a loop where it's continually like restarting something. And it's like, you might not notice, but you need to be able to notice, right? And then you need to be able to troubleshoot it and understand what's going on here. So you need the logs and whatever visibility to look into that and understand what's going on and fix it.
Yep.
Just because infrastructure is close to my heart and a common kind of topic between us. One of the things that I've found interesting and challenging, and that I think is a challenge for the industry with infrastructure as code and these kind of platforming kind of things and providing infrastructure, is we get these infrastructure as code tools like a Terraform or OpenTofu or Pulumi or whatnot. And they're like, okay, I can use this, write the code that specifies what my infrastructure is, and then I can kind of apply it. But then you get into, it gets messy really quick with how am I going to configure different environments? How am I going to kind of deploy it? How do I orchestrate first this needs to happen, that needs to happen, and so on. And so I feel like a lot of the teams that I work with and that I visit, like, they've got all kinds of custom scripts and whatnot to do all this. And in some cases, this is more code than the actual infrastructure code. And so one of the reasons I bring this up with you is because obviously with the work and the products that, and things that you've written about are really in this space. So I'm kind of curious about your take on all of that and where we are and where we're going.
Yeah. Our industry is wrappers on top of glue code on top of wrappers on top of, it really is. I laugh at that, but it's actually not unique to the DevOps space. So again, coming from this kind of app dev background, one thing that I saw is many companies, especially as they get larger, they don't use the app dev tools directly either. They use them through wrappers. So for example, you're not using Spring Framework as your Java web framework. You're using your company's custom wrapper on top of Spring Framework, which, as you said, is sometimes bigger than the original framework. It's sometimes so custom and complicated that it's its own beast. And that definitely happens in the DevOps space as well. Lots of companies don't use Terraform or OpenTofu directly. They use custom wrapper scripts, or they use TerraGrunt, which is an open source tool we built at Gruntwork. Lots of companies don't use Kubernetes directly, right? You're not just using raw YAML, you're using Helm or Kustomize or Cap or, one of these tools. So we have a lot of wrapper code in this world. And I think there's some pretty good reasons for that. Part of it is the tools themselves are focused on, and probably should be on, what they do best, which is like infrastructure, right? It's an infrastructure as code tools. So they're built to configure a server or configure a route or configure a security group. But in the real world, that's not the only problems we have to deal with, right? We have to think about higher level things like, okay, I have a route, but how do I configure an entire environment or multiple environments? How do I fit that all into CI/CD? How do I lay out my code so it's not all copy pasted everywhere? How do I version it? How do I roll out changes and handle errors? So there's all of these questions that a lot of tools leave largely unanswered. And so the answer that a lot of people provide to those questions is wrapper scripts. With TerraGrunt, what we're trying to do is essentially give you a standardized off-the-shelf answer to a bunch of these questions. I often think about it as a framework for using Terraform or OpenTofu at scale. And the word framework is a very deliberate word choice. I think of it in the same way that Ruby on Rails is a framework for using Ruby for web applications, right? It's a framework. It has all these pieces and opinions. Here's how you lay out your code, and here's how you're going to test your code, and here's how you're going to configure your code. All of those answers come out of the box with a framework. And essentially, that's what TerraGrunt is trying to provide for the Terraform and OpenTofu world. And the reality is this, and this is, again, something I learned very much over and over again in the app dev world, is you can't not have a framework. People love to have this debate. Oh, I hate frameworks. They're too heavyweight. They're too whatever, opinionated. So I only use libraries.
Yep.
Well, congratulations. Either you use a framework or you create your own.
Yeah.
And the thing that happens when you create your own is it's probably not going to be very well documented. It's probably not going to be very well tested. It's probably not going to be maintained. And we all know this because we've all been at companies where we're using those frameworks, and then whoever it is that created that wrapper, if you will, leaves, and development grinds to a halt because no one has any idea how to maintain it, extend it going forward. So generally speaking, as ecosystems mature, the one-off wrappers get replaced with open source, well-documented, well-maintained frameworks that are opinionated, but that's a good thing because you need it. You need to answer those questions. Saying you can't not have a framework is the same as saying you can't not answer the question of how am I going to manage environments? How am I going to lay out my files? How am I going to handle errors? You just have to figure that stuff out. So that's where I see it. And our industry, DevOps, this infrastructure automation, it's not as mature, I think, compared to some of the core programming languages and web frameworks. So we're still figuring that out, but I would expect to see a lot more of that, a lot more of these kind of frameworky solutions that give you out of the box the answers to many of these questions.
Yeah, that makes sense to me. And I like what you said about the opinionation, right? Because I think a lot of times when people have issues with a framework, it's not that it's opinionated, it's that they don't agree with the opinion.
Yeah.
Or maybe they don't understand the opinion, right? They have,
Yep.
A lot of times people come into it and I think, okay, this is how I should approach it. And you take the tool and it doesn't work that way. And then they try to bend it to fit. And then it's like, this tool is terrible.
Yep. And you have an interesting decision to make there because you can choose to say, I don't agree with this opinion, and then throw out the entire framework. Yep. In which case, then you also have to fill in 600 other opinions of your own and maintain them forever. Some frameworks let you configure or replace some of their opinions. And those are usually the really mature ones. And those are the ones that tend to be successful in the real world, where they give you most of the structure. And then that like 20% that you maybe don't want to do that way, you can swap it out. And I think that tends to be the better thing for the industry in general, is where 80% is the same as the open source thing, as this company and that company. And so, you can join a company and you know how to use Terraform and OpenTofu the way they do, as opposed to showing up and spending weeks and weeks learning their custom wrapper scripts and their custom this and that, which then falls apart anyway after a few months.
Yeah. I think the other thing on the is with these is a lot of those opinions are things that actually maybe you don't need to care about once you get past it, right? So I'm thinking about that. You used the analogy of Ruby on Rails. I always think about Maven and Ant for some reason, because I used to do a lot of build stuff, right? And so with Ant, you would build this really custom. Every build was a whole different set of custom Ant scripts. And then Maven was like really opinionated and had like a really fixed way to do it. And then people were like, I don't like the way it organizes files. I want to have my source code here, my test folder like that. And so you could customize it, but then you have a really weird Maven setup. But at the end of the day, it's like, well, do I really care? Or should I just kind of go with it and spend my brain power and our team debates on something that matters?
Exactly. Yeah. Instead of arguing, where to put the curly brace, just install a code formatter and just never think about it again, ever again. That's it. I think that's the better way to go.
And then speaking of kind of where things are going, as we're saying, I think we agree on, we're still learning a lot as an industry and we're not kind of where we're going to end up. There's been a lot of chatter over the past year or 2 years, maybe even a little bit more around, and it's been categorized different ways. It's like, DevOps is dead is one of the kind of things. But I think the way I would categorize it is a lot of questioning of infrastructure as code, as whether, is that really a useful paradigm? And is it time to kind of move beyond that? So again, I'm curious what your take on that is.
That is another huge topic. Yeah, the short version. I think what we're seeing is legitimate questions with kind of the limitations and the frustrations with some of the tools that are out there. And they're real. Like it doesn't make sense to dismiss them. They are better than it used to be. I remember configuring everything manually and like, no, thank you. Don't want to go back to that. But that doesn't mean that there aren't still huge improvements we can make. As I said, we're not that mature with our tooling yet. And so there's all sorts of problems that are really hard to solve using today's infrastructure as code tools. Things like, how do I import existing infrastructure, right? Yes, we did ClickOps. Yes, there's like 10 million accounts already out there. How do we get them into this tool in a way that's like actually effective and scalable and secure? Or how do I deal with manual changes, right? I did all this work to set up beautiful infrastructure code. And then we had an outage and 10 people came in and did a bunch of stuff by hand because, everything was on fire. And now the code doesn't in any way match what's actually deployed. Testing is hard. Using these tools at scale is really hard. So there's a lot of unsolved problems. And I'm kind of of the opinion that seeing new paradigms as ways to solve these is both good and bad. It's good because sometimes you really do stumble across a new idea that is genuinely transformational, and that's a very good thing for the industry. It sometimes makes me a little sad because occasionally the thing that's missing is just maturity in your existing tools. And I feel like that's one of the hallmarks of like becoming more of like a senior engineer in our industry. You go from showing up and saying, hey, you know what'll fix this? A totally new language and a totally new framework and a totally new this and that, to realizing like, there's actually value to the stuff that's there. That's probably why you have a job in the first place. And if you iterated on that stuff, maybe you could actually fix those problems faster and more effectively.
Yeah.
That said, the new paradigms are interesting. And there's a bunch of them out there. I'll list just a handful really quickly because I think they're worth looking at least. I will also add one caveat. I'm a firm believer of the choose boring technology approach, if you're familiar with that. And having been bitten by brand new technologies many, many times in my life, I'd rather not. So these are things I'm looking at kind of at a distance, and I don't think most of them are really ready for production yet because this stuff takes years. But they're very interesting, and maybe in a few years they'll be mature enough. Mm-hmm. So one interesting new approach is infrastructure from code as opposed to infrastructure as code. The idea there is there's tools like Amped, Nitric, Modal, a bunch of others, where they basically look at your application code. So let's say you have a Node.js app, takes HTTP requests, talks to a database. They look at that code and they infer the infrastructure that you need automatically. And so then if you say, hey, I want to put this app in AWS, maybe they spin up some EC2 instances and an ALB and an RDS database. And if you tell it to do it in GCP or Azure, it can do whatever the equivalents are in those clouds.
Yep.
So that's really cool. And in a sense, you don't have this giant pile of infrastructure code to maintain. You just have your app code. So that's pretty neat. It does feel super early days with those. And I have a lot of questions about how, for example, it's not really pure app code. You actually have to annotate your app code in a very specific way so it knows, oh, this represents a database and whatnot. But it's still an interesting thing in the sense that, to me, this is like cross-plane done right. Instead of just having piles and piles of YAML code, it's like, no, my application knows what it needs, and you go figure, spin that up in
as long as you don't have to fill in the details. Like, you don't want your application code to become polluted with, and here's screenfuls of like
exactly
how to actually configure the database and the storage.
Exactly. How leaky of an abstraction is it going to be going to be one of the biggest questions. And there's some real challenges. Like, how do you specify, I want to update this app with a blue-green deployment, right? Without annotating your code with all sorts of fancy things saying this must be blue-green deployed. Like, there's some real challenges in there. Yeah. But it's a very interesting approach.
Yeah, I agree.
There's another one from the system initiative guys. I don't know, have a fun word or buzzword for it, maybe infrastructure as model, where what you see on the surface is they give you a visual programming interface for your infrastructure, which to me is like not really the important part of this thing. What they seem to be doing is they model your infrastructure instead of as code, like a pile of Terraform code, they model it as data. As a model of data, like in a database. I don't know what they're using under the hood, but that's conceptually how I think of it.
It's like another phrase is infrastructure as graph.
Yeah, that might be an even better term for it. And so you have this data that says, I have a server over here and a load balancer over here and a database over here. And the data, depending on the type of thing that you're managing, each of those has code attached to it. I think they use TypeScript for it. So here's a little bit of code that knows how to deal with a server. And here's a little bit of code that knows how to deal with the database. And you can edit that code, which makes it really easy to do things like testing and validations and a lot of custom behavior. And the model does a really nice job of maintaining relationships because, as you said, it's a graph. So really interesting approach. Honestly, to me, the weakest point of it is the visual editor, because in all the years that I've been looking at programming, I can count on basically 2 fingers the number of visual programming tools that have actually succeeded, especially at scale. It's exceptionally rare to make those work. But the modeling things as data and as graphs, I think is very, very interesting. Yeah. And then the third one, which is really cool, are, again, I don't know the official buzzword that we'll all end up saying in the future, but I've been referring to them as interactive runbooks or interactive playbooks. So if you look, there's a lot of companies that have static playbooks, right? A wiki page or a Google Doc that says step-by-step, how do we deal with an outage, or how do we spin up a new service, or how do we spin up a new environment? The interactive runbooks say these things should be little web apps that you build out that are interactive. So they have buttons on them. They have web forms. They can render a chart. They can render a graph. And so instead of a static playbook that says, go to Grafana and look at these charts if there's an outage, it just shows you the chart right there in the page, and the logs, and a button to try to redeploy the service, and a history of all the deployments, and whatever else you need is right in there. And some of these things under the hood are managed as code. So this is another as code kind of tool. And if you squint at it, you could really start to imagine a lot of your infrastructure managed this way, right? Instead of a CI/CD pipeline defined as some YAML and GitHub Actions, it's suddenly an interactive playbook that says, here's how we build our app, and here's how we package it, and here's how we test it. And you can run that locally, or you can run that automatically when there's a git commit. So there's something really interesting. It's kind of like if you've used Jupyter Notebooks in data science, it's like a Jupyter Notebook for DevOps is kind of how I've been seeing it. And boy, they're really fun to play with, I have to admit. It's just enjoyable, honestly. DevOps can be very painful, and these tools are actually fun. So those are also cool to see. So anyway, I really like seeing these new paradigms. Yeah. I hope at least 1 or 2 of them will be something really useful in the future. But I also think they're not quite mature yet, so they'll take a little bit of time before we're all using
I agree.
them.
I think this is stuff to kind of keep an eye on. And it's really interesting. And it'll be really interesting to see where it goes. Well, Yevgeniy, thanks for taking the time to talk to me. I just kind of want to make sure that people know about the book. That's from O'Reilly, Fundamentals of DevOps and Software Delivery. I found it really, really pragmatic and useful for people having to deal with a lot of the challenges that we've talked about, managing your applications and infrastructure and getting them into production, safely and reliably and all those kind of things. So definitely recommend it. Thanks, Yevgeniy. Thanks, everyone.
Thank you so much for having me. Great to chat with you.
Thanks, everyone, for tuning in. Bye.
Thanks for listening to this episode of the GoTo Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.